let's get into our tonight's topic, which is testing. We have two speakers for tonight, Petros Plakogiannis and Nikos Voulgaris. Petros will present performance assertion during the functional testing, and Nikos will present TDD in action. And I'm looking forward to both of these. And we have the sponsors to thank, and the first one is JetBrains. I'm sure many of you know JetBrains from their wonderful development software. We also have Yodec as a sponsor, which is a digital signage company. We have also Ferlo, which is a financial services company, and also has offices here in Heraklion. And I also think that we have some ads going on in our board right now for Ferlo. And any of you interested in sponsoring the stuff, you can do so via Open Collective. You can find us there. And now some things about our community. The goal is to bring people who are passionate about software and technology in general closer together. And what we always say is that it's your community. And by community, we mean that we have no titles, presidents, secretaries, and that kind of stuff. We have got no elections, and we are trying to be open as in open source. And what's the catch? The catch is that we need active participation. And how you can do that? You can join us on Slack. We have a very active Slack channel. You can open an issue or a PR in our Github Repo. And of course, you can participate in our team meetups if you want to see how all this thing gets organized. About the meetups themselves, they're taking place the second Thursday of every month. Of course, you can attend, you can suggest topics, and you are welcome to present your favorite topic as well. All this is happening through the meetup.com platform. You get notified for new meetup events, and please RSVP, and you can also send your feedback via the meetup.com platform. We also have the GitHub repo, in which you can open an issue and have your say in general. About the meetup topics, you can propose new meetup topics to the DevStaff org team. There's always an org team member hanging around in Slack. We also have one upcoming meetups form, which you can fill out. And then the org team is responsible for curating topics and selecting the most promising. And we set off to find speakers and prepare events for the next months. And this is where we also need your help. You can propose a speaker that you know, or it even could be you. I mean, you can present your favorite topic. It might also be something that you don't really know, but you are interested in, and it's the opportunity to find more, about it. We also have some events that we're calling them hack sessions, and they're hands-on events. Some examples include like group learning, Docker, HashiCorp, drones, whatever, technology or software related. You can also propose it on Slack, and we are happy to facilitate a hack session and let you realize it and organize it as well. Another big part of our community is the jobs board. We actually have a job board on GitHub, which you can, if you are a company, you can post some ads there about your job openings. And if you're looking for a job, it's always the first place to look at. We also have a jobs channel on Slack, which is quite active, I might add. And as a community, we follow a code of conduct, which is can be summarized to, yeah, let's be nice, or at least civil. And this is the time that I ask if any of you has some announcements to make. Anybody? All right.
I guess
Anyone?
it's not the job announcement or anything like that now.
Yeah, I mean, it's, yeah, it's fine.
Yeah, if I
some...
I can just take 45 seconds maybe. Just
yeah,
to,
sure.
Just to let you know, I mean, I think many already know this, and we have a we try to be very active in the Heraklion and the Crete community, both in DevStaff and other places also, university and so on. But specifically the DevStaff community, we're really in. I mean, we have Stavro in our team who is part of DevStaff very actively, but also generally, this is actually how we established Fairlaw in Heraklion. DevStaff was our kind of gateway into the community, and we started Fairlaw with 1-2 persons, and today we have 4 people full time now. Actually, Valantis, who lives in Sweden, have been working here for 10 years for a big corporation, so he's now joining Fairlaw to have the chance to come back to his island and live there and work with Fairlaw. But to be honest, we are growing a lot rapidly. We will double the tech team within just 3 months. And looking at what we are trying to achieve is we are scaling our financial services that are unique in the market, and we have a lot to do. We will go and expand to other countries and so on, and we really want to build this in Heraklion. We want to have kind of our core tech team building the scalable global solutions from Heraklion. So I just want to say, and we are sharing this with many companies in Heraklion who wants talented and amazing people to be joined, but also Fairlaw. So if there are people out there thinking to join a company and work tech, that's very, very interesting, and we're learning new things every day. Fairlaw is absolutely a place you can look at. So happy to check out our job ads and what we do, and we're happy to talk to anyone. Thank you. Thank you really for giving us the opportunity to talk here also. Appreciate it.
Thank you very much. Okay. So I guess we can start our meetup with our first presenter, Petros. The stage is yours.
Okay. Okay. Hello guys. Hello everyone. First of all, thank you for inviting me to your meetup. So many developers against one tester. I love a lot of the Crete Island. I was there in the university. I have a lot of friends there. I know a lot of people from you, like Nico Fanudaki. I have been in the nice meetup, in the nice conference of Agile Conf in Crete from Eurostat. So I'm very happy that I'm going to present Times API in your meetup. I have been working as a software tester for 30 years, and I'm pretty sure that you want to watch my presentation because of one specific word in the title, and this word is the performance. But I'm software tester, and you know, as software tester, performance is not my favorite thing. Software testers usually don't know or don't have time to do performance testing. What if I tell you that you can add a layer of performance checks into your functional tests with minimal effort? 2 years ago, I had the opportunity to attend to the Selenium conference in Berlin. One of the main talks there was about Times API by Marcel Werkel. Marcel is the head performance engineer at GoDaddy. If you don't know, GoDaddy is one of the biggest web hosting companies in the world. I think it's in Arizona or something. So I found very interesting this topic. I collaborated a little bit with Marcel. I invited Marcel in our meetup in Athens. I became committer in the project. I have done various questions and improvements, etc. So today I would like to tell you how you can set up and install the Timex API. While you are reading the performance golden rule from Steve Saunders, I would like to tell you that when we talk about performance testing, okay, our minds, first of all, Steve Saunders is the head engineer in Google, okay? So when we talk about performance testing, our minds go towards to load and stress testing. But load and stress testing is about the backend, the capacity of backend, and what it can do under specific load. But is something in the front end. Testers test mainly the GUI. We care a lot about the user interface. So is something in the front end? And if yes, what and how we can use it? I'm not sure if you are familiar with the W3c Performance Api. Every major browser out there, every browser, has a built-in API that is called W3c Performance Api and stores timestamps for all these events that you can see on your screen. From left to right is a full page load. For example, everything starts with DNS. You have to do DNS lookup. Then you have to do TCP connection to your web server. Then at the change request, browser sends a GET request. The server gets the request and sends back the data. So when you have timestamps for all these events, you can calculate a metric that is called page load time. But other things too, for example, the server's time to first byte. That's a very interesting metric to look at because it says something about your server. I'm going to say it one more time. All these timestamps are into your browser. Go to your favorite browser. Okay, go to a site, for example, DevStaff. Open the console. Type performance timing. And you are going to see all these timestamps for these events. Okay. DOM loading, redirect start, response end, etc. So when you have all these timestamps in the browser, you can collect them and you can use them. That's what GoDaddy did and developed the Timex API. So what is the Timex API? Timex API is a Node Express-based API that I'm going to show you later that collects data and visualize them with Kibana, performance data. And the idea is to add a layer of performance metrics into your functional tests. So how it works. Okay, imagine that on the left is your script, your automation script. For example, your Selenium script. Okay, you do functional tests with a Selenium script. And on the right is the timings API. There are two post requests from the script to the API. With the first request, you grab a snippet of JavaScript code from the API. You get it back, you decode the key of the response, and you inject it into the WebDriver object. While your tests are running, okay, while your WebDriver is running, performance data are captured and posted back with a second request, and the response is a Boolean field that users can use for assertion. Now, this Boolean field indicates whether the page load time is above or below a baseline or SLA, a service level agreement. What is baseline now and SLA? Okay, at this point, I have to say that one of the main features of API is to collect statistic data and to generate a baseline. I have to mention that the baseline is not calculated on the average of page load times, but it uses percentiles. Without going into statistical details, because percentiles is a little bit a weird concept, percentile is one of the most common methodology that is used for performance data management. Okay, so the baseline is generated from all the page load times, but not from average, but a percentile of the page load times. The SLA is a service level agreement. For example, we can say that our page should have page load time 6 seconds. Okay, so all this data are saved into Elasticsearch and visualized in Kibana. It might sound complicated, but it's not. And in order to simplify the communication with API, I mean, from the client side, from your Selenium test scripts, 3 clients have been implemented: one JavaScript client, one Python, and one Java. I think that right now is some people implementing the Ruby client. I use a Java client, but it's very easy to install and set up the API client if you want to use the Times API. Let's see how we can install and run it. Okay, GoDaddy uses Docker. Marcel Verkel made it very easy. You can go to the repo, times Docker, you clone the repo, and you run Docker compose app in order to spin up the 3 containers: the timings, the Elasticsearch, and the Kibana. Okay, they are all in this box in the repo. We're going to see it in action this, but before seeing in actions, I would like to tell you that, as I told you, I use a Java client. This is just a print screen with a corresponding dependency in the Maven project, in the POM XML. And let's see in action. So I have captured some videos, because if you go now in the GitHub, you're going to see that the latest version of Docker has some issues, and Marcel tries to solve these issues. So I just created yesterday a ticket there. So in order to install the API, you just run Docker compose app. You spin up the 3 containers. You can see that the Elasticsearch is with blue color, the timings is with a clean color, and Kibana is with yellow color. It just takes a few seconds. So we refresh the local host. The Timings API is up. It has been documented with Swagger. If you want to play with endpoints, you can try here various things in order to check the API. There are a lot of information here. We refresh the Elasticsearch is up. And we refresh the Kibana is up too. I would like to say that it's very cool that GoDaddy provides us a lot of graphs and metrics by default. Right now, of course, you cannot see anything because we haven't run any test. We don't have data, okay? But we have a lot of, as you can see, a lot of graphs here. So let's say that we are going to test the site of the Ministry of Testing. And let's say that we want to test the home page of the Ministry of Testing, and the SLA for the home page of the Ministry of Testing, 6 seconds. That means that the page load time for the Ministry of Testing, 6 seconds. Okay? So from the client, if you are going to play with a client, you're going to see all these classes and methods that you can use in order to inject your code, as I told you some minutes ago, and to do these calls with API. So I'm going to run it with the JUnit. I use Selenium. So I have added the Timings API inside my Selenium script. The site opens, and we can see that we get a lot of information here. And the test failed. We are going to see why it's failed. Oops, sorry. So let's see why. First of all, if we scroll up, we can see that we have all this information that I showed you before from the W3c Performance Api. Okay, we collect all this information here. But the interesting also is that we have this information for any resource of the page. For example, for CSS, as you can see, or for an image, or for a query, we have the duration and the metrics for any resource. And if we scroll down, we can see that the SLA is 6 seconds. The baseline is 0 seconds because we ran the test only once, so we haven't created the baseline yet. And the measured time, so the actual page load time is 6.3. That means that the page load time is above the SLA, so that's why the test failed. So we have other information here, if you want to check about. But let's go to Kibana. Now we have data here. Let me tell you something about the data. Here we can see the welcome page. Okay, this specific table is not the actual page that you can, the actual table that you can view when you are going to download the API. When you do Docker Compose app, I have modified a little bit this table. Because why? Because I use the page object pattern in Selenium, and I wanted to see for every page of the site the page load time. If you are going to download the Timings API from the scratch, here you are going to see URLs and not the pages. In my code, I passed as I'm passing constructor the Timings API together with a driver, with a web driver. So when starts running the driver, starts the timings API too. So I wanted here to have the pages. So we can see here the page load time, the percentile of page load time, as I told you, the percentile of baseline, here we can see a table that is pass versus fail ratio. And this is one of my favorite tables here because you can see the actual page load time and the baseline, not the percentile, the average. The percentile is not the average, but let's say the average, not the percentile, but the actual page load time and baseline per date and per time. Okay, for example, here we can see that this specific date, the test failed in this page with this page load time and baseline. Let's run it once more to get more data and to explain you more about the graphs. So this time, we are going to run the test. And you are going to see that the test passed. Because I'm pretty sure that you are going to ask it in the question, I'm going to tell you now, it's not passed because of the cache. As you know, WebDriver object, Selenium WebDriver, starts the browser with empty cache. Because a lot of people think that now it's passed because the cache. It's not this the case. The WebDriver always starts a session with empty cache. Okay. So let's see what. Oh, again now. The video. Sorry. Let's go now to the. Okay. So why is passed? Let's scroll up. We can see now that the measure is 5.7. The baseline is 6.3. Now we have baseline, and it's the previous page load time. Okay, we have run it twice. The first page load time was, if you remember, 0 seconds. The second page 0 seconds, and the baseline was 6.3. Now the baseline is the previous page load time plus 0. Okay, so it's the baseline 6.3. The SLA is 6 seconds, but the measured is 5.7. So it's below the SLA, it's below the baseline. So the test passed. Okay. There are various reasons why a test before failed and now is passed. Maybe it's the CPU of the client, of the machine. Maybe it's the network. In order to get more probably results, more precise results, you have to run the test a lot of times. Okay? And as you run the test a lot of times, you get a baseline that makes sense. You can check the baseline, how it's calculated exactly in the GitHub, in the corresponding repository. Marcel has all the details there. But as I told you, the 70th of percentile of the page load times, it uses also the date and the time and other parameters. So here we can see that we have 2 times visit the welcome page. Now the page load time, the percentile is 6.2, and the percentile of baseline is 4.7. We can view here that the test, one test passed, one test failed. And in this very nice table again, we can see that this time in the same page, the test is passed. Okay, the actual page load time and the actual baseline. We have other information here too. For example, we have some information about which browser do you use. Who is the tester that does the performance testing, or if you use baseline or not. Maybe you don't want to use baseline, you want to use only the SLA, or if you assert against the baseline or not, because if the assertion failed, then the test is going to stop. Maybe you don't want this. You want the test run all the time, so you don't want to have the assertion. So we have a lot of information on this dashboard. But there's one more dashboard that's I think it's very cool. It's about the resources that I told you before, that we get information about for any resource of the page. Okay, for example, the duration of the CSS, of the images, etc. We can see various things here. And in order to be more precise, I'm going to show you a real example. So, of course, I have deleted here the URL of the company that I installed the Dynamics API. So my company sent me as for consulting in a insurance company, a big insurance company. So they had a site that you do all these insurance things, authorization tasks, policies, members, etc. The site was not performed well in the front end. They had some issues. So here there are results. Here you can see the queries. Okay, the REST queries that are occurred in these specific pages. And the most obvious result is that this query here, query member coverage limits, that is used in various pages. I don't know if you can see it here, is very slow. The 70th percentile of duration can fluctuate from 13 seconds to 29 seconds. So the users that uses this site wait 29 seconds to get the results from the query. Of course, this is not the actual performance. It's not neither load nor stress testing, but it says something. It says something that your query has an issue, and the developers have to fix this. So I think this dashboard is very cool. Again, here this is a press screen from the consultant that I did into this company. You can see here on these pages, we have run a lot of times the Dynamics API. We get more precise baseline, etc. But we have one more dashboard. If you go again to this nice table, you can see here, click here the waterfall. This waterfall, I guess you are familiar with the Chrome, is the waterfall of the Chrome. Okay, if you go to the Chrome, you can see this waterfall, it's the same. Okay, but here you can view other information too. For the specific test, the page load time, the baseline, the first byte. Okay. You know that the waterfall provides a clear visualization of when each resource of the page is loaded and how long each stage of the loaded process takes. But it's the same as the Chrome. If you go to the Chrome, you can view all these things. But below, there's this table. You can view it here, that you can view again all the resources of the page. We have the request start, the duration. We have here a lot of information also. And you can filter all these things by type If we scroll up, you can see that we have this here filter mechanism that, for example, if you click at the CSS, you are going to view only the CSS. So I'm pretty sure that you like this API. I have used it by myself in 2 companies as consulting. I'm going to tell it one more time. This API is not ready, full, completed. I mean, if you go to the GitHub, you're going to see that there are a lot of issues yet, but you can download it and play a little bit. It's not exactly performance testing, but you get some clue, you get some evidence or some information about the front end performance in the client side, in the UI. So that's all. Thank you a lot. If you have any questions and I can answer, I'm open to answer. Thank you a lot.
Thank you, Petros.
Thanks a lot, Petros. Very nice.
Any questions from the audience? Please shoot at Petros.
Hey, it's me. Thanks a lot, Petro. And can I ask you a question? Given that there is an SLA in place, would you go as far as putting these tests on your pipeline and just fail the pipeline in case they just don't pass?
No, we didn't add this in the pipeline yet. Haven't done this, but we want to do this. It will be very interesting to have in the pipelines.
Yeah, mainly I'm asking because I guess they fluctuate, as we saw. Sometimes when they're on the verge, they may pass or they may not pass. Sometimes you may fail your pipeline because you didn't meet the SLA just one out of, I don't know, every time.
Yes. The golden rule for Timex API is to run your tests often and use Kibana to review the results and the stability of the results against the baseline. If you run a lot of times your Timex API, you're going to get proper results that make sense. So yes, I think always the first time is going to fail, if I remember correctly. But as you build up the baseline, I think everything will make sense. And it's going to be nice to have it in the pipeline, in my opinion.
Thank you.
One question from my side. Hello. Thanks, Petro, for that presentation. I'd like to ask you, what is the best time to inject the driver from your test? I guess that it won't be correct if all the elements are not loaded. I don't know.
Yes, the best time to inject the JS code in order to get the results from the browser is after a page has fully loaded. So in my Selenium script, I do wait until page is loaded, okay? Or you wait for something, for an element. So everything is going to load it, then to get the metrics from the W3c Performance Metrics API that is in your browser. Because if you are going to get metrics earlier than the page is going to load it, then you are going to get wrong results. So you have to wait until the page is loaded. But you can do this if you use Selenium or Protractor or something like that. You can use these methods, wait until element or wait for Angular, if you do Angular, I don't know, in order to wait the page to be loaded.
Okay, thank you.
Can I ask a question as well? I'm not familiar with front-end testing, but does timings API or what you presented can be combined with some crawling in order to parse the whole website, or it should be one by one page manually inserted in the tests in order to make it fully dynamic for the whole website? I mean.
Yes, you can do as I told in the presentation. I modified a little bit because I wanted to test page by page because I used the page object pattern in my tests. But the main idea that Marcel implemented this is to parse all the site. So while your Selenium tests are running, it's going to pass all the site and you get the result, and you're going to the result per URL, as I told you.
So
but
okay.
Yes. But I just wanted to do page by page because we had these issues with the queries. So I wanted to see in which page exactly the query has a problem.
Okay, thanks.
I think also Yorgos has raised his hand.
Yeah, thanks for the presentation, Petro. I kind of had a similar question to Nikos, but I also had a comment to add on what was said after. It does sound to me well, I haven't looked at this before, but it does sound like this is more of a tool for exploratory testing, right? And not really something meant to be used as part of a pipeline. We've also been hit by this kind of flakiness or fluctuation in when running UI tests. As Petros said, there's a lot of, the client CPU might be overloaded, yes. And you get broken builds in your pipeline. So what we did, this is what I wanted to offer, is what we did in order to get UI tests reliably passing in a pipeline was to always run them with localhost access. So no internet access for, like, the whole application is deployed in a local environment, no internet access allowed, which means, yes, that, analytics things don't work, and kind of, various other third-party services need to be mocked and so on. But that's been the only way we've been able to get, reliability and constant green pipelines with UI tests, to kind of limit down the system under test, if you like, so that it's not the client and the whole internet, but just the kind of the application. Take the network out.
This is very good. At the end, I totally agree with your comment. Yeah, but okay, as I told, maybe they're going to have some issues with the test machine that CPU bound, or during the JS parsing, etc. But if you're going to run a lot of times the times API, you're going to see that the baseline is going to take sense. And I totally agree that maybe this is better to run it in the local host to not have
and I also wanted to emphasize your comment that these client issues are more often than you might think originally. So yeah.
For me, this tool is something like as the tester runs, the Selenium scripts or the WebDriver IO or Cypress test, to say, okay, let's see what's going on, to have an evidence of something is going on in the performance, let's say, of the site. And I think it's very handy to use it.
Yes. Yeah, exactly. For the exploratory side of things, this is great. And I mean, these graphs are a big, it's much easier to explain performance issues when you can show them in graphs, especially to non-technical folks. I mean, this is a great tool from that point of view.
and you have it in the box. I mean, you're going to say to your manager, I created the graphs. But
Nice.
but it's nice that GoDaddy has all these things.
So the thing is that you can set up this timings API and stuff like that, and Kibana and Elastic in a couple of hours, let's say. But in order to do what Yorgos said, to isolate it from all the other external dependencies, you're going to spend about 2 months to mock them.
Okay. Okay. When you do, it depends. For example,
yeah, just
in this client that was the insurance company, it was so obviously that when I did manually testing, and I click execute, for example, to get the authorization results, I waited a lot of seconds. I said, "What's going on? Something is going on. Something is wrong here." But with this tool, we found that this query has an issue. So let's see and let's explore what is going on then at the backend later from developers. But all this thing is open source. It's still building the API. So if you have ideas or you want to contribute, it would be nice to make it better.
nice. Is there any other question for Petros?
Actually, speaking about open source, Petro, I wanted to ask if you were planning on open sourcing the part you mentioned, the trick you did with the pages, so you don't show URLs. But
yeah, the truth is that I have it. Okay, the Java client that it's as I told you, it has been implemented by someone else, not from Marcel. So I cloned this repository and I changed it a lot by myself. I have it in my GitHub. I can send you later in the Slack channel if anyone wants to download my client of my Java client for this Times API. Because if you are going to use the other Java client, you're going to see other results.
Okay.
nice.
We can add it at our GitHub repo for this meetup, so everybody will have it.
If I'm going to show you, had a lot of discussions about all these things. For example, one problem is that for example, what is the first resource that should be loaded? For example, usually the first resource is CSS, and when we should get the page load time, for example. But this was in debate. But I think that, as I told earlier, that the best time is to take it when the page is actually loaded, fully loaded. So you have to wait. You have to wait the driver to load the page properly.
Okay, good. I think that we are 8 minutes late, so just a reminder, there is once more post for our form for the giveaways today. So please fill in your name and your email if you want to participate. And thanks once more to Petros. And let's move on with Nikos Vulgaris and TDD in action.
Okay, hello again. Thanks for having me, guys. It's always a pleasure spending time with you and Jordan Meet, and I like it very much that I'm here tonight. Okay, so first things first, before I even introduce myself, I'm very aware of the fact that I tend to speak quickly, right? And I sometimes tend not to enunciate that well. So feel free at any given moment if you either don't understand what I'm saying or there's background noise or the connection quality is bad or anything, feel free to interrupt me and shout out that you can't really understand what I'm saying, and we'll fix it again. Can you see my screen? Can you see my awesome PowerPoint?
Yes.
Okay, cool. All right, so I'm Nick. I'll answer either one of these. And I'm a software engineer, and today we will be talking a little bit about TDD, test-driven development. And actually, I've given this talk in the past, and one of the reasons I enjoy giving this talk is that a lot of people tend to think that TDD is a little bit, so I'd say, academic or poetic, or something that's great in books or for tutorials, but you can't really apply it on your day-to-day job. So it feels really great to give that talk and actually make this more tangible for a lot of people. If we're complicated, I would like to see a show of hands of how many people actually use TDD, but let's keep this. Before we dive into TDD, I would like to spend like a couple of minutes to talk a little bit about what is a feedback loop, right? So when we talk about a feedback loop, is the very concept, the very idea is that we perform an action somewhere in the world, in the system maybe or somewhere, and then we sit back, like we relax, and we observe the side effect because we messed with the world or with the system in a way, and that's bound to produce a side effect. And the side effect is that what we're actually interested in. And the things that we actually observe the side effect, then we get to get feedback out of it, and we get to learn stuff, right? And that's a complete cycle. And then we get into another action, observe another side effect, get some feedback, learn a little bit more. And that process is actually what can make us good at something, right? And I'm in particularly not restricting this to software engineering at the moment, but I want us to be familiar with this concept. And by the way, it's a whole different talk, but if anyone comes to you and talks to you about agile software engineering and agile methodologies, and all that focuses on sticky notes on walls and not on the feedback loops thing, then something's wrong with this guy, but that's another talk. All right. So being aware of what is a feedback loop, or at least of the essence of it, of the high level of it, I want us to talk a little bit about the cycle of the test-driven development. The test-driven development is actually a methodology. It's a tool. It's a way in which we can write software, one more way in which we can write software. And the whole idea is summarized in this state machine, right? We have a very simplistic state machine. All we have is like 3 states and 3 straightforward transitions from one state to another. The initial stage is the red stage. So we enter the red state, and the objective there is just to write a failing unit test, right? So in essence, we have a system, and all we want to do is want to impose the need to ourselves to add something to the system, add a piece of behavior, add a requirement, add a business need, you name it, right? Something that the system is not currently doing, and we want to impose to ourselves the need to make the system do that something, right? So the way we do that is we write the test, and what makes it a failing test is that, of course, the code is not already there to make it pass, right? So, and that gives us the transition to the green state. So as soon as we have the requirement, the need, we have a problem, we have a test that fails, then we get to transition to the green state by actually making the test pass, right? And then we've done something quite magical. We've introduced a new set of behavior, a new kind of behavior to the system. And the system exhibits a behavior that it didn't use to exhibit before we did this process. But not only have we done that, we also have a test that acts as a safety net, right? Because now we know that not only the system does what it's supposed to be doing, but we can also prove it, and we can also verify it very easily, very cheaply, with a click of a button, right? And that gives us an enormous amount of comfort and easiness to transition to the yellow state, which is the refactor state. One thing I didn't mention intentionally is that the way we transition from the red to the green state is slow. It's meant to be like that. It's encouraged to be like that. All we want to do is go quickly from red to green, right? We want to make the system do something new, something that it didn't used to do. And we don't care about being sloppy. We certainly don't craft or design code. We make copy and paste, and all of these no-nos are actually encouraged here. All we want to do is go quickly from red to green. And the reason for that is that as soon as we do that, we can move to the yellow, to the refactoring state, and then having the safety net, now that not have the system covered by a test to prove that it's doing what it's supposed to be doing, now we can actually make it pretty. We can design it. We can make sure that the code is well crafted and maintainable and everything. And as soon as we do that, we just jump back to the red state and congratulations, you've added a new, tiny step of behavior to the system. And the point actually is that you keep on doing that until you finish your work, right? Okay, so this is we will be mainly writing code. That's why the slides are so sloppy. Can you actually read anything here, or should I just try to work with the phone a little bit more?
It's quite clear.
Sorry, it's what?
It's clear, quite clear.
It's clear, all right, great to know. Okay, so the kata that we'll be using here, first of all, it's not mine. I don't claim the ownership of this work, of the solution to the kata. Actually, it's a kata recorded by Uncle Bob, Robert Martin, and feel free to go online and search for it on his website. But the reason that I'm using something that is not my work is mainly that I want this piece of code the next 30 minutes or so to act as a means to an end, the end being that I want to communicate as much as I can about testing and development, and I want something to work as a bridge, something to help me do that. So we'll take the solution and we'll work step by step on it, and I will be explaining myself thoroughly, hopefully, throughout the solution, right? Okay, so if we jump back for a moment to the cycle, we will be referring to the cycle a lot. I told you that the red state is the initial state. Oh, yeah, and I forgot to mention the objective, right? Okay, so forgive me about that. The objective is very simple, actually. It's intentionally very simple. All we want to do is write a data structure, a stack data structure. And let me just remind you that stack is a data structure that works in the last in, first out fashion, right? So if we, for instance, push 1 and then push 2, and then we pop an element, we get 2, and then if we pop another one, we get 1, right? So coming back here to the cycle, we want to start with the red state, right? So we have nothing actually. Most likely, you're not going to be able to read my package structure, but there is absolutely nothing in the production code. I've just created a simple empty test suite, which reads stack specification, right? And I've actually proved myself that I have an environment that's working by executing this thing. So the very first thing I want to do, remember, I know what I want to do. I want to implement stack, right? So I need to impose that need to myself, right? First things first, I need class. I need stack class, right? And in order to do that, I will start off with a very simple first test, which is that the stack should be empty when created, right? That's a very simple requirement that I'm trying to inject the system, and it will definitely help me create the stack that I need, that I know that I need to create, right? I mainly like starting my tests from the assertion, right, and then to the act, and then to the arrange. I hope we get used to this a bit here already. So assuming that I have a stack, I should be able to call the isEmpty method, right? And expect that this thing will be true. So I need a stack, and the way I'm gonna work with it is that I'm gonna need it like something like DevStaff stack initially. The reason I'm doing that is if I just write stack, the ID will think that I want to import the Java stack. So I just don't want to do that, and I want to make it explicit to the ID. So I want to stack. And given that I have a new stack, I want this to be empty, and I need it given, and actually we'll make some sort of patterns there too. Now that's the red state. Remember, we are already there. We have a failing test. This test won't even compile. That means that it fails, right? So what I want to do is I want to create this little guy here, and I want to put it in the production code, and I want to bring this guy right and close this guy. And I'm pretty sure that IntelliJ has needed the Crete class, so I'm going to convert it to Java. Now this guy is compiling, but I still need to make this empty function. But before I do so, let's take a moment to realize what we're actually doing here. We have the red state, the failing test, and all of a sudden I've introduced the need to create a function that's called isEmpty, right? That's the design. That's the design phase that we're in. We're actually designing the production code. Because this is going to be part of the public API of the stack class that I'm going to be making, right? So I actually made a couple of decisions here. That it's like it's going to have a method that exposes the fact of the knowledge of whether it is empty or not. That's decision number one. Decision number two is that this method is going to be called is empty, and decision number two is that it's going to be Boolean, right? It's going to return a Boolean value. So I'm going to go ahead and create this, and let's just use the primitive. And remember, I'm going to make this guy fast, right? I want to be sloppy, I want to be cheap, I'm encouraged to do so, and I want to make this pass quickly. How do you propose that I should make this one pass? It's a question, really. I'm expecting answers. No one?
Just return true.
Yeah, exactly. I'll just return true, right? Just because I always want to see the test fail, so I might return false for a moment, but definitely that's what I'm going to do. I just want to see the test fail for two reasons. So that's parentheses. First, I should know that it fails when it should be failing, and second, I want to see the diagnostics are here, which is spoke. There's an excellent work here. So just return true, right? And that should make it. All right, yeah. Now we moved on to the green state, right? Quick and dirty, we moved on to the green state. I know that stack's always true, but I don't care about this for the moment being. And the reason why I don't care about it is that I only have a single requirement, right? And I'm meeting this requirement. And I'm going to go to the refactoring state. And all I want to do is actually rename this guy. And now I'm going to call it stack. There's not going to be any confusion there. And what I'm going to do in the refactoring state is that as soon as I make a change, as soon as I make a modification, I'm going to re-execute my tests. And that's the reason, that's the essence of having a safety net. The essence is that as soon as you make a move, a refactoring move, then you can re-execute the safety net, the suite of tests actually, and then you make sure that you didn't break anything while refactoring this guy. And this focus giving me a hard time here. This is actually equivalent to that, because by definition that's an association with spoke. So another refactoring move in the test suite, another execution of the safety net, right? And that's the way that we're moving forward. Now, the key one of the key things in TDD, I've already given you one key thing, is that the transition from red to green state should be quick and dirty, right? And then you get to do things right. But that's key. If you don't do that, you're bound to fail doing this style of TDD that we're doing. The question number two is, which is the next test? That's actually a vital question. Because the order in which I'm going to decide to write the unit tests will actually shape the production code for me, right? Because that's a key question. Any suggestion? What should be the next test case? There's no right or wrong, by the way, right? I'm just trying to keep you engaged and communicate as much as I can.
When you push an item, the item is pushed, something like that.
Actually, thanks, Nicholas. I'm actually very happy that I got this reply. I've been meaning to ask you a question down the road anyway. What will happen if we do that? If we say that, for example, when I push one and then I pop, I expect one to be popped. How will I react to this failure? What should I do then to make it pass? I will basically force myself to almost write the whole stack, right? But that's not the point here. The point here is to move on incrementally. We want to keep on adding. Excuse me. We want to keep on adding tiny pieces of functionality, and ideally, we want to keep this cycle, this feedback loop, fast. And when I say fast, ideally it should be second, right? Red, green, refactor, red, green, refactor. Maybe spend a little bit more time on refactor, but definitely red, green should be fast, right? So I definitely don't want to do that, because if I do that, Nico, then I will spend a lot of time to go from red to green, and that's going to work. I'm going to write a stack, but it's not going to be in the TDD, style of things. So the key here, when we do this kind of TDD, the style of TDD, and I will talk to you a little bit later about what I mean by style. The key, one of the key is to go for the most degenerate cases first, because that way we will actually scaffold the production code, the structured production code, and then it will be very easy to keep our cycles fast when we actually reach to the mid. Right. So let's say that I want to that stack should increment its size when pushed, right? That makes sense. So what I want to do is I want to assert that stack.size equals 1, and in order to do that, I should do stack.push, and let's assume we make an integer stack here, right? A stack that handles integers. And for me to do that, I also need a stack. And notice that I'm not using the stack that I've created above, because that's going to be refactoring, and I'm currently in the red state. And okay, I may not be so I may not go that much by the rules when I'm writing production code using that, but this is a demonstration, and I feel that's something that I need to communicate to you. Right. So we want size function. It's going to return an int. I keep on making design decisions here. That's in the signature, right? Public int, it's a return type, the name, size, etc., etc. For the moment being, all it can do is maybe return 0. We don't really care. And we also need a push function, and the push function is going to be void. It's going to take an integer as an input. Let's call it element, right? Element. And it can do nothing since it's void. I'm going to rerun the tests. I still want to see it fail, right? I want to know that this test fails when it has to fail, right? And the easiest way to make this pass is to rerun this. Now I'm happy now both tests pass. I'm in the red and the green state. There's not a lot of push back. Oh, no, actually there is something that I can do here. Is that I can create this setup method that I talked about and bring this further up here. Maybe split this and keep this guy here, and then we don't need them. This should be expect, and this should be like that. Let's format the code and run the tests, and this should still pass. Right, and I still know that's fake. So let's talk a little bit about the technique here. We're going back to the red state, and I now know that I need to force myself to make this guy work better and to really work before I actually move on, right? Because I keep on scaffolding the structure of the production code. And the technique that I'm going to be using is called triangulation, right? So when I have a single unit test that that expects a certain number, I can just hard code this number. But triangulation is all about adding a second or a third, usually a second test case, with a different input that expects a different number. And then I force myself to actually not hard code the result, but actually make the code work. And I can just add a second insertion here. And expect that the size should be 0. And now that the first guy is going to fail, I guess, hopefully. Right, it's the expected 0 by root 1, and now I force myself to solve the size thing, and all I'm going to do is add a private int size for here. I'm going to initialize it to 0, right, and I can increment size here, and then I can just return size here, and if I'm not mistaken, this should work. Right, so we find ourselves in the green state once again, and now I want to make a refactoring, and the refactoring is that this guy should also return this size equals 0. And I'm kind of sloppy here. I could add a test, triangulate, and make myself, implement this empty. For example, asserting here is empty is false, but there's not really need to do that. I mean, as soon as you get familiar to an idea, you can add some code and stuff like that, if you ask me. Okay, so I guess for the sake of symmetry, the next test should be that the stack should decrement the size when popped, right? Again, we're forcing ourselves to create more contract here to make design decisions. We don't have a way to pop elements, so we will just create one. We expect that the size of the stack should be 1. In order for that to happen, we need to push something in the stack, and then we need to pop the stack. And we already have a stack, so we don't need to create one. And I don't have a pop function. I'm not going to even bother, running the tests. They are failing. I know that they are not compiling. I'm going to make this method. Notice that obviously pop has to return an integer, but remember, we're just trying to make the test pass, right? And quickly, and just cover the requirements on the left-hand side, nothing more than that. So I'm not going to do that. I'm just going to let it be void, because that's all I need for the moment being, right? And in order for this to pass, I should just decrement the size, I guess. And that should make it work. All right. What about the next test case?
Get a value when you pop?
Yes, that actually sounds reasonable, but I'm a little bit concerned that this will make me do exactly what I mentioned earlier, that it's going to make me walk a very large step, and I wouldn't like to do that. I would like to avoid that. So I want to keep on adding small pieces of functionality. And trust me, if we weren't, going through this together, this would all be a matter of 10 seconds from one source file to the other source file. So I want to do something like stack should overflow.
Size should not be negative.
Right. Yeah, we can totally write this test. Let's write it actually. But how would you propose to write this one? Because we'd have to pop an empty stack, right?
Yep, exactly.
All right, but I think that we should design it a little bit more carefully and expect something to happen when we pop an empty stack. Perhaps have the stack underflow, maybe throw an exception or something. What do you think, Joel?
Yes, exception sounds fine.
Cool. So the stack should throw an underflow exception, which we don't have at the moment, when empty and popped, right? So with an empty stack, which we have, we expect that's the way of spoke to expect an exception, an underflow exception, right? When is this going to happen? When we just pop the empty stack and we don't have this little fellow here. So I'm just going to actually I'm going to create another to make the go class again. I just this exception, right? Let's make this guy derived from the runtime exception. We don't care about this. That should do it. Right? I'm actually doing tests, that's why I'm staring at the screen. We were expecting an underflow exception, which we didn't, which was not thrown. And therefore, let's just go here and now safeguard close in case is the size is equal to 0, but you ask me to pop, then you're going to get a very nice underflow exception because you can't pop an empty. Right, and for the sake of simplicity, you know that I'll add the stack should throw an overflow exception when pushed past its capacity. And it's not necessarily have capacity. Just let's assume that this is in the requirements as part of the exercise, actually. So what I want to do here is that I want to expect an overflow exception, overflow exception, which I don't have once again, and I'm going to create it. I usually like having my production code on the right hand side and the tests on the left hand side, but that's totally a matter of taste. That's why I'm just going to do this guys around. So if I just, assuming that we'll have a size of 2, let's push 3 items, right? Of course, this is going to fail because we don't currently have the capacity in our production code to support size, right? So to support the capacity, excuse me. So what I can do is like, I won't tell you to start. Oh, yeah. It's what I was trying to keep clear of before. So I'm going to rewrite the tests. Thankfully, we're in the same state. What I can do is that I can add the capacity here, right, and inject it into the constructor, which I currently don't have, but I can create. So I can assume that I'll get capacity here, and maybe bind this guy. And bind this capacity. And I also need capacity initialized, and then I can add the safeguard close to the push method, and I say that, you know what, if the size already equals the capacity and you ask me to push, it's not gonna happen. We're gonna get another flow exception, and that should make it pass. Right. I remember that we are in the green state, and we're currently, getting some traction, and we're moving forwards. I'm going to step ahead and do a refactoring. I realize that it may not sound obvious at this moment, and what the reason I'm doing that, but I actually want to make a point out of the exercise, so you'll realize it in the future. I want to use a static method. I want to use a make method. And I want to say something like static make, right, instead of using the constructor. And in order to do that, I will make the constructor private, and I can add a public static stack make method that accepts the capacity as the argument, which is going to just return a new stack with the capacity. Right? That should work, I think. What I've done is essentially that I've explicitly disallowed the direct instantiation of the stack, right? I'm using a factor that instantiate. This is a design pattern, if I'm not mistaken, but you'll see the reason in a moment, actually, right? And since I have this, I think I'm obliged to actually make a test about the legal capacity. So I think I should go ahead and say that stack should throw an legal capacity exception when initialized with negative capacity. All right, so I'm expecting an illegal capacity exception, which I have. And when do I expect that? When I say start to make -1. Right, and let's create this guy here. Let's extend the runtime exception as doesn't matter. This should fail, right? I've split it up a little bit, but I guess you'd be bored if I didn't do so. I mean, you'd be bored if I was just with the same pace, and that fails. That's beautiful. It fails for the right reason. I was expecting any legal capacity exception, didn't get any. So we will just add a safeguard clause here and say that, you know what, if you ask me to initialize make this stack with the capacity to be less than 0, we're gonna get a legal capacity exception, and that should suffice to make it work. Right, and now the moment that you're actually looking for, I guess, we're going to add the very first test that touches the heart of the production group, the meat, as I referred to earlier. So the stack should pop X when X was popped. Right. Notice that here I'm not going for the whole functionality. I'm just aiming for a single element. Right. I could do maybe 2 elements and just build an array on the right hand side. I'm not going to do that. I'm going to keep on moving incrementally because that's the whole point of doing this thing, right? So I want to say that I expect the stack pop actually to be equal to 1, assuming that I already have pushed 1, right? I'm going to use the stack that I already have in capacity of 1. Obviously, it's going to fail. It's actually going to fail to compile it because this guy is not doing anything. Yeah. Right. So I'm forced to change my signature here and make this guy an int, return int, and let's persist. It's really bad here. Let's save him. All right. So we need an element. right? And all I want to do is persist this guy here, save him in memory, and then I can comfortably return him what I'm asked to. And notice that we keep on adding both behavior and tiny bits of structure at the same time. I mean, it's the first real test case. I believe that's how you're thinking. And we already have like 50 lines of code, 41 lines of code, or whatever, with a real structure, with a factoring method, with this design decision to disallow the direct instantiation of the object, with the size, these exceptions and the safeguards clause about the legal capacity exception and everything. My point is that we're building our way towards the standard. We're building our way.
Are you okay?
Yeah, I think I'm fine. Hope my car is also fine. Anyway, so now let's moving on. Let's keep on moving on, and we'll obviously add the next test, which is that stack should pop y and then x. When x, y next, when x and then y were pushed, right? That should actually do it for the whole stack functionality. So we want to do stack with pop, and we expect this guy to be the second element that we pop, which is 2, and then we want to expect the first element that we push, which is 1. For that to happen, we should say stack push 1 first, and then stack push 2. Okay, let's run this guy. I bet this is going to fail. The reason being that nothing we do actually adds 2 elements in our memory. Right, so the way I'm going to do this is that I am now going to refactor this guy, which I already knew in the beginning that's going to be an array or some sort of data structure, but I didn't want to get there. I just wanted to capture the function, the requirements on the left-hand side, and I want to make a point here. If this blue part of the test suite was missing, and if we assume that all the rest of the test cases were the requirements for a business case, for a business need, for a story, ticket, you name it. Of course, this is really ridiculous when we're talking about the stack, but if we had a requirement about a stack that could host just a single element and could underflow and overflow and have capacity, that would be it, right? Whereas I bet that if we didn't start using TDD to implement this guy, we would definitely have used an array, which, come to think about it, would have been pure over engineering, right? I mean, the point that I'm trying to make is that as we push requirements to the production code with the form of new test cases, then we make sure that we eliminate over engineering so long as we are focused on making just the test pass, right? Just make the test pass, nothing more than that, right? Anyway, parenthesis closed, and I'm going to make this an array, which should be like that. And I'm going to instantiate I'm going to instantiate this guy as a new integer array of the capacity. So when I make a new stack with the capacity, I would be able to hold that many elements, right? And now, of course, this guy's here break. And what I want to do is that I want to persist inside the array now and not just single elements. So I want this just the element. And on the other side here, I want to return this side, but I want to remove not mistaken 4. So terminate this should work, I guess. Okay, great. Now we're in a good place actually. We've built a lot of code, right? The stack is working. Not only it can host 2 integers, but n integers, and it's pretty obvious. We can write tests if you want to put that, but I don't really think that there's a need to do so. So what I want to do is that I want to make a very special test case, and I want to say that the test the stack should throw an underflow exception with when the capacity is 0, and it is pushed, popped, excuse me. And you might wonder why on earth would you like to do that? I'm just doing it for the sake of the exercise because I want to read somewhere, right? Switching super for a moment. So I expect an underflow exception to be done, right? Yeah, but I need a zero capacity stack to do that. Zero capacity stack in order to pop the zero capacity stack, which I don't have a zero capacity stack. I will create it here, or I'll actually do it the old-fashioned way. Zero capacity stack. It was real. Excuse me. It was start with make with capacity 0. That should do it. What do you think this test is going to do? Is it going to fail or is it going to pass? Okay, let's find out. I hope you haven't just, haven't all lost it or something. If that's the case, feel free to shout me and you can jump back and then, work more slowly maybe. And anyway, the thing is that this test passed here, right? So we went straight from the red state to the refactoring state, and the reason is that actually we wrote the test about the requirement that was already in the system, but I'm a little bit uncomfortable with the way that this is implemented, right? Remember that we are in the green state, so we can feel free to move on to the refactoring state. So what do we do here? We call stack.make with capacity 0, right? So we go through the constructor, excuse me, and then we initialize an elements array with 0 capacity, which we know that we won't be using anyway because the capacity 0. This guy is always going to perform this equality check for no obvious reason at all. This guy is always going to fall in this if state, and this guy is always going to fall in this state. So basically, that's not a very well crafted solution, one could say. And since the tests are green and we can move to the refactoring state, I'm going to go ahead and say that I want to extract an interface out of here. And you will see in a moment why I'm doing that. So I'm going to rename the original class into bound stack, right? And I'm going to, I don't know if you can read this, probably not, but anyway, I'm just have a dialog with concerning the methods that I want to pull up with me. So I'm going to take this empty size push and pop. I'm going to do this refactoring. I push my fingers, that will work. All right, so what did we end up with? We have a stack interface that was just created by the refactoring move that I made, right? And now this guy that we used to work with is no longer called stack, it's called the bounded stack, and it implements the stack interface, right? These guys here are overridden, as you can see, and the corrective move that I want to make is that here I want to work with stack and with the bounded stack, right? And I'm going to do exactly the same thing here. Of course, I'm going to write the tests because we are in the to run the tests because we are in the yellow state, and I made a pretty heavy refactoring move using the ID. I extracted the interface and I named things, and I want to make sure that my safety net will go, thumbs up, everything's good, and it just did actually. And now you realize why I did that in the first place, because I want to go here and maybe I want to create a private static class that's called zero capacity stack. Which will definitely implement the stack interface, right? And the ID is going to get me out here. Okay, so let's implement this, guys. On a zero capacity stack, and it's empty, it's always going to return true. There's no question about it. Size is always going to be 0. Any push will throw an overflow exception, and any pop will throw another flow exception. And what I want to do is that this guy is currently not used. So what I want to do is I want to go here to the and now you basically see the reason why I made this static factory method in the first place. And I know that I jumped ahead a little bit, but even if I hadn't done so, I could easily do this refactoring with the factory method just before I extract the interface. I just wanted to, but this step is already heavy. Didn't want to make it even more heavy, so I just did that in the beginning. So I want to say that if the capacity of the stack that is going to create for you is 0, then I will return a new 0 capacity stack for you. And I'm going to execute my tests again because I'm refactoring. And then we'll notice that they still pass, but in this case here, we're not going through this whole unnecessary code that we used to. We've actually hidden a very beautiful abstraction here, and we work with the 0 capacity stack. And we can stop here. It's 20 to 9. We can stop here. We can definitely go ahead implementing the stack. It won't make a difference in the world. We can go ahead using top or pick or find and adding more elements, exceptions, and anything that you might imagine, or actually that's in the requirements. The reason is that I wanted to make some points about TDD, and I wanted to reach to the state so we can discuss a little bit about this point. So I'm going to go back to the presentation. Okay, we've got our hands dirty, and let's just focus on some key elements and some key takeaways, what we showed here about the testing development methodology. First of all, this is an incremental approach, right? It has to work in small steps, otherwise it won't work, or even if it does work, trust me, you won't get any benefit out of it, so there is no really reason to go ahead and apply and use TDD if you're not moving in small steps. On the contrary, most likely you will find yourself either getting lost or just implementing the whole thing anyway with a huge, a very big test that took me 20 minutes to write and and whole production code that took me, I don't know how many minutes to write. But that's valid, right? Absolutely valid. A lot of people do that. There's nothing wrong with that. It's just not TDD. That's what I want to say. I talked to you a little bit about the two keys in TDD. The first one is that you want to go from the red state to the green state very quickly and dirty. You want to add the increment very quickly to the system, and then you can concern yourself with how well crafted your solution is when you have your feature added, and it's also covered by a test, right? That's the first thing. So I don't want you spending too much time here because we can lose the benefits of TDD once again. And the second key element is what is the next test? If I jump back to the code once again, you'll see that actually we moved very, very gradually, very, very slowly. We made ourselves create a stack, and we made ourselves create a method deciding if it's empty or not. And then we dealt a lot with the size and what happens when it's empty and we pop, and it's full and we push, and exceptions and overflows and the capacity. So we work our way incrementally, and it's allowed us to scaffold to build the production code. And then I think you remember that when we actually reached to these two test cases that are actually the goal, it was very easy. It took us with the discussion, it took us 2 minutes to make a modification in the code. So the order in which I'm going to decide to write the tests is really critical here, absolutely critical, because if my first test was this one, again, that would have been very valid. The production code would work and everything would be perfect, but it's just not TDD, right? I mean, there's no reason to do TDD for that. I don't know if you understood it, but I've said it a lot of times using different words sometimes. The whole mentality is summarized by this phrase here: first make it work, then make it better, right? So we want to impose the need to ourselves to create something. And we want to create something quickly. We want to make it work, right? We want to add something, and then we can make it better. Having the safety net, right? That's the whole mentality here. And actually, trust me, makes it go fast. I understand that you think that TDD maybe makes it go slow, but it makes it go fast because it makes us make progress in a steady pace, right? Not going back and forth all the time. And you will realize that as a system gets bigger and bigger, but this discussion. All right, that's a general testing point, but I don't know if you understood that, but we created executable documentation. So if I come here and I just wrap these guys all up, I can just read through the documentation of the production code. So if I was to create this class for Nikos, for example, and Nikos was like, hey man, did you finish your implementation? I would be like, yeah, sure, just go to the stack spec and see what it's doing for you. So stack is empty when it was created. It increments its size when pushed, increments its size when popped, throws XYZ exception when XYZ things happen, etc., etc. Right? So we created an executable documentation. And by the way, we get this for free when we apply TDD. We apply TDD. When we're done, we got the suite of tests, and the suite of tests acts like an executable documentation, which we already know. right? But we get that for free with the TDD style. And I left this slide last, and now you'll understand why we reached the point that we did the whole refactoring with the extraction of the interface and everything. And Uncle Bob names this quality as test contravariance. I think he owns the term. I think I've definitely heard from him. Anyway, that's not the point. The point is that test contravariance means, in very simple words, that the structure of the production code is not mirrored to the structure of our test code, right? If I go through the package structure, I know that you can't really read that most likely, but we have 5 source files here and just a single test file that tests these 5 source files. The reason why this is useful is actually that this is a form of loose coupling, right? When we do one production file, one test file, one production file, one test file, this creates coupling. It creates coupling because the tests know the structure of the production code, and that makes refactoring harder. And you know the story, I guess. There's not really to elaborate on it. Okay, just a couple of more quick things before I wrap up. Most of the questions I get when I try to, give people a very broad idea of what TDD is all about is that they have the sense that, okay, it's great if you want to implement a stack, but I don't really implement stacks in my day-to-day work. I deal with, I don't know, maybe a backend service which has an HTTP layer, a database layer, and a whole complex and really logic in there. I wouldn't be able to do this thing. And the thing is that that's a whole different discussion on its own and has a lot of things to be said. I'm not going to do this discussion at the moment because it's going to take like 2 more hours, trust me. But I just want to throw a teaser here. There's this, what we did was called classicist TDD, or AKA Chicago style. There's also the London style, which is called the outside TDD, which is what I use for my day-to-day work. There's a prerequisite. You have to master classicist TDD before you can learn and apply outside TDD. So basically, all that outside TDD does is that it wraps the inner TDD cycle with an extra step that has to do with acceptance tests, functional tests, you name it. It's the same thing anyway. So that actually makes it easy, makes it plausible, and makes it useful to work with TDD in an actual, say, backend application or Android application or whatever that is. So, but trust me, one cannot just directly go to the outside TDD if one does not already have mastered the good habits of TDD. Before we close, there are a couple of books that I would like to recommend to you, and they are the ones that got me into TDD in the first place. These and Center from Conclusion. Anyway, the first one is Text-Driven Development by Example by Kent Beck. Trust me, this book is gold. It deserves a lot. It's worth a lot. Not only is the basic mentality behind TDD methodology in there, but there are also some beautiful sets of examples and some beautiful sets of ways of thinking when doing software engineering. For example, the triangulation technique that I talked about is discussed in this book. And if you happen to get into TDD and like TDD and maybe read Text-Driven Development by Example from Kent Beck and you want to explore the outside in TDD, there's this great book called Software-Oriented Software Guided by Tests. Definitely worth your while, worth your time. And I also have a blog post on my personal blog that I compare the two styles if anyone's interested. Right, I hope that wasn't too long. I definitely hope you didn't lose me and not interrupted me in the way. I'm open to questions, discussions, and everything you want to talk about.
Thank you, Nikos. That was a very nice presentation. I enjoyed it very much.
Thank you. That's great to hear, actually.
Thanks a lot. Yeah, it was awesome.
But I guess that if no one has any questions, to do a very good job, actually.
Yeah, I guess we have questions.
I do have a question, if you don't mind.
Absolutely. My pleasure.
Hi, Nikos. Thank you. I really enjoyed the live coding session. I wanted to ask you, are there any drawbacks when you're using TDD? And if yes, how can you know beforehand, or should we like go and preach TDD tomorrow, or Yeah, because we saw a couple of advantages of TDD, right? The fact that it's incremental and you're doing minimum work and stuff like that. But other than that, are there any drawbacks?
Yeah, absolutely. And perhaps it's my mistake that I didn't include some of them in the presentation. There's definitely a huge drawback. This being that this thing has a very slow learning curve, right? I mean, one has to really devote time and energy and study a lot to master TDD. And it's very easy to get discouraged, right? If you just, study a couple of concepts in TDD or just watch this presentation and try to apply it to more in your work, it's not going to happen, I guess, most likely. So the thing is that it has a great, a very, very slow and flat learning curve. It just takes a lot of time, and to actually make matters worse, it's very difficult if one is working on a code base in a group of people with a team, and he's the only one that applies TDD, or maybe there's a portion of the team that applies TDD and the rest of it doesn't. Because actually TDD, at least in my humble opinion, is a design tool, right? So you end up with a differently designed system when you use TDD than if you weren't. And if some team members use TDD and some not, it's going to be hybrid, and it's going to look a mess, and no one's going to ever cherish the good parts of TDD. Additionally, it's really hard to work in an already written application, in a legacy code application that's not developed using TDD, because you definitely realize if you try to apply TDD in there, that it's very hard to test something that wasn't designed to be testable, right? It's almost certain that if you don't do TDD, some parts of your application won't be testable by definition, and therefore you won't be able to apply it. But having said that, I don't really, I was never for opinions like go and preach TDD or TDD rocks, or you should be doing TDD. That's not the point of the presentation. The point of the presentation is to tell you something like TDD is out there. That's what it looks like. Feel free to play with it. And the way I did like 5 years ago, and now I've been making my living 5 years with this thing, right? There's no, I don't like dogmatic opinions, right? There's no right or wrong. That's what it is. I use it. I like it. It suits me. It suits my team. Maybe it's not for you, right? I don't know if I answered your question.
Yeah, thank you. You covered everything. Thank you very much.
That's great. Thank you.
I think Yorgos has raised a hand. So.
Yeah. Thanks, Nico. Thanks again. The live coding was great. I wanted, could you please bring up the red, green, yellow?
Absolutely.
Right. So we have a kind of visual, so I can try to express my question. So we've written the failing tests, we've made them green, and now it's time to refactor. And as we're refactoring, we're breaking some tests. Does that happen?
Yeah, I guess you already know the answer, right? But that's a great question nonetheless. Absolutely, it happens. There is no silver bullet, especially in software engineering, right? And TDD is a good tool in my opinion, but it definitely doesn't solve every problem. And that happens. It happens a lot, and actually it happens when you usually have to alter, to refactor the public API of classes. At least in my experience, that's when it happens the most. And it's painful because if you're in the refactor state and you realize that you're breaking tests, you're basically not refactoring, you're rewriting, right? Because when you're refactoring, you just leave the test suite as it is, work as a safety net, and then you go ahead and work on the code, or work on the code or leave the code as it is and write the tests. If you actually balance between the two of them and actually modify them at the same time, you have absolutely no guarantee that the system will be behaving the same way that it did before you apply these modifications. So it happens. It's scary. It's horrifying. But okay, let's actually devote 1 more minute, if you don't mind, to that question, because there are trade-offs, right? In software engineering, in my opinion, everything is a trade-off. There is no correct answer. There is no wrong answer. A lot of discussion has been going on online about this this question mainly, and the main difference between the two styles, between the classes and the London style, the outside utility, is where design takes place. And what do I mean by that? I mean that if you notice that, and I pointed out a couple of times, when we were doing the stack kata, we were designing in the red state. We were designing about public APIs, naming things, signatures, everything, right? And that that brings us a very heavy refactoring state in the green state. And that was the showcase actually when we extracted the interface, because that was very complex. Even with the aid of ID, we still extracted the interface, and we made a private static class. That was a lot of work, and if you can imagine doing that in a big application, it's a lot of pain, and it's actually something that puts back a lot of people when they want to work with DDD. Now, on the other hand, the outside-in style works in a different way. Sorry, I actually said something wrong here. We were designing in the red state, but we were mainly designing in the refactor state, right? Because we were doing all the signatures and the public APIs in the red state, but then we extracted a whole interface or a public private class or a static private class in the yellow state. So some design was taking place in the red state, but a lot of it was taking place in the refactor state, which made it brittle and made it easy for the tests to break. But the outside utility embraces a different approach when you design in the red state. And if you design in the red state, you get a little bit more coupling between your test suite and your production code. You don't have that much of a contravariance as we did, but you have a lot lightweight. You have more lightweight refactoring states. Actually, it's a bit hard to put it into words. I'm going to share my blog post actually. That's not shameless promotion of myself, but I actually delved into this point a lot. So I'm going to share a blog post that's okay with you.
That's a fair plug. Don't feel bad about it.
All right. There's a lot of conversations about this. There's a lot of conversations. I'm sure you're familiar with it, but I'm just mentioning with the group.
I'm not sure if someone else had something more to say on this topic. I also wanted to ask if you've found a better test framework than Spock.
All right. That's kind of a fine question, because when I first came to Crete for Agile Crete back in 2019 and I met you, I hadn't actually used Spock in my life before, and I remember doing a kata, and you were using Spock, and it was looking a little bit weird. And I was a major fan of yeah, it was. And I was a major fan of JUnit and Mockito. I literally knew it outside in, and then I joined Blueground like a month after the session that I talked to you about, and now I've been using Spock for like more than 1.5 years. And I had to use Mockito and JUnit the other day for, I don't exactly remember what it was, maybe kata or something, I don't exactly remember. And I just hated it. I was like, where's Spock? Yeah, absolutely. Guys, give it a go. Spock's great.
I haven't used it for a while now, and just seeing the code now just made me long for it again.
Yeah, great tool actually. And there's I don't know if you know Kostis Kappelonis. He's a Greek guy. He's heavily involved in the JHA community. You should know him, right? He's offered a book on Spock.
Yeah, it's a pretty good book. You should. I mean, everyone should who's interested. Look it up.
It's what I went for when I joined Blueground and I didn't know about Spock. I read this book. Okay, so I guess that's it. Thank you very much for your time, guys. I hope it wasn't tiresome. I hope you didn't lose me. Once again, the intention was to let you know that TDD is something that I've been making my living with it since at least 5 years now. It's a tangible thing. It's not for academia. It's out there. Feel free to play with it and familiarize with it. And trust me, it's worth it, right? It's worth a shot. I don't actually suggest that you use it, but try it out. Really. You're bound to learn things, and you're bound to expand your mind. Really.
Thanks a lot once again, Nikos.
Thank you guys for having me
Nice
here.
presentation.
Thanks, Nikos.